The basic gas laws are important to help understand how refrigerant behaves in the vapor compression cycle. These basic gas laws are Charles' law, Boyle's law, and Dalton's law. Absolute values for temperature and pressure are used for gas law calculations. Charles' law describes how gases tend to expand when heated. When the temperature is increased, sensible heat, the pressure increases, and vice versa. Please note, this is provided the volume remains constant. Charles' law can be observed inside the compressor when the pressure on the refrigerant is increased from a low pressure to a high pressure, which causes the temperature of the refrigerant to also increase. If the volume of the refrigerant remains constant, but the pressure is increased, the temperature of the refrigerant is increased. For example, for reciprocal compressors in old split systems, when the piston moves down, the pressure is decreased and the temperature is decreased. When the piston moves up, the pressure is increased and the temperature is increased. In rotary compressors in new split systems, the compressor sucks in the refrigerant as a low pressure vapor and compresses it to leave through the vane as a high pressure vapor.
Pressure temperature charts are tables or graphs of the physical relationship of temperature to pressure for a saturated refrigerant, and they vary for each refrigerant. Pressure temperature charts are used as a tool by technicians to help determine the system operation when taking temperature and pressure measurements on different parts of the system. When all of this information is known, the technician can use a pressure temperature chart for a particular refrigerant to help determine if the refrigerant cycle is operating as intended.
The pressure of the refrigerant and the temperature of the refrigerant have a direct relationship. For example, R22 refrigerant has a pressure of 814 kilopascals at a temperature of 20 degrees Celsius. Charles' law also applies to all types of cylinders when exposed to heat or when cooled. This includes refrigerant cylinders, MAP gas, acetylene, and oxygen cylinders. As the temperature increases, the pressure increases inside the cylinder, and vice versa. Cylinders that are exposed to sunlight can cause the substances to increase in pressure through the increase in temperature. Therefore, you must avoid placing cylinders which may be overfilled in direct sunlight, as it could result in an explosion. Boyle's law explores the inverse relationship between pressure and volume. When the volume, or space, for gas is decreased, the pressure is increased, and vice versa. Please note, this is provided the temperature remains constant. Boyle's law is also found within a compressor of a split system. For example, in reciprocal compressors in old split systems, when the space decreases, the pressure of the refrigerant increases, and vice versa. In rotary compressors in new split systems, when the compressor compresses and limits the space for the refrigerant, it causes the refrigerant to increase in pressure. Dalton's law explores the relationship between partial pressures. The law states, the total pressure of a mixture of gases is the sum of the partial pressures of each of the gases in the mixture. For example, if you mix two gases, the total pressure will equal the sum of their individual pressures. The total pressure of air is the sum of the oxygen, the nitrogen, the carbon dioxide, and the water vapor pressure. To summarize, Boyle's law states the absolute pressure and the volume of a gas are inversely proportional. Dalton's law states the total pressure of the mixture of gases is the sum of the partial pressures of individual gases. Charles' law describes how gases tend to expand when heated or pressure is applied.